All right, so the last step here in the assembly of the robot involves putting the lid on top and mounting the Lidar onto it. So when you first get the Lidar out of the kit, this will come as 3 parts. You'll have the USB adapter, the cable that runs onto the Lidar, and the Lidar itself. So before you install it, make sure that you plug in these 2 connectors. It's pretty foolproof. 3-pin to 3-pin, 4-pin to 4-pin. And you plug this end to this USB breakout board. And note, this is a USB micro, so a little bit old-fashioned. You can mount this right onto the lid using the 4 M2.5 screws that you'll have left over. So for that, you can just set this down on its face. I've got those floating around here. So with it, we'll just set it down, get it lined up, and then start screwing it into place. And get that more in frame there for you guys. So right now for sensors on this robot, we just have the Lidar, and eventually you're going to be adding a Raspberry Pi camera onto it. The Pi camera will be mounted using the holes both either in the front or back of the robot, depending on how you want to orientate the robot and which direction you want to be driving in. That'll be an additional 3D printed mount that you'll just bolt right onto this. For future upgrades, we'll be able to have additional mounting points on the back of this chassis that could allow for mounting of additional sensors, anything that you think might be interesting. So that's something that just by reprinting this top plate with that universal mounting platform, you'd be able to add those additional sensors up here. So now that we've got this mounted, we'll just kind of snake that in right there so it's a little bit more out of the way, and get this all lined up on top right here. So we've got our USB-C cable sticking out the back there. So there we go. Now we've got it all lined up. We'll drop in our M4 bolts for holding this on, and go around and tighten them up. These M4 screws are a little bit tight the first time you put them in, as you're forming the threads into the plastic, but after that they go in a lot easier. So if just using a small tool like this gets a little bit tight, having something a bit bigger like this can be handy if you're doing it quick. If not, you'll just have to put a little bit more force into it. Or if it's too tight, different printers have different tolerancing and different quality outputs. And if yours is a little bit on the tight side for holes, you might need to take a drill bit that's just a little bit bigger than the diameter of the hole to it. Make sure it isn't too big so that you end up stripping out the hole. But there's doing something like that can help reduce the amount of torque that's required. And we'll just get these 2 in, and then this will be a finished robot. If you guys have any other questions about the assembly process, let me know. The next video will be about cloning the SD card so that you can have be able to put all of the code necessary for running this robot right on using that cloning process rather than needing to get all of the dependencies installed correctly for running this. The process of installing those dependencies is a good learning experience, but it's definitely quicker just to have that SD card there ready to go. So at that, we can plug in our USB right like this. I'm using a 90-degree USB cable. It's just what I had on hand. In the parts list, I have a just conventional USB-C or micro USB cable that's short one like this. Whatever you have on hand or whatever you think would work best should do the trick. and you can just kind of route it like that to get it out of the way. So there we go. We have a finished robot that's all assembled and ready to drive. The next step, like I was mentioning, will be getting the software set up and running, and then we'll be able to actually drive it. So again, let me know if you have any questions, and this is a robot.